Filecoin is a decentralized data storage network built by Protocol Labs that allows users to sell their excess storage on an open platform. It acts as the incentive and security layer for the Interplanetary File System, or IPFS, a peer-to-peer network for storing and sharing data files. Filecoin turns IPFS storage system into an algorithmic market, where users pay storage providers in Filecoin's native token, FIL, to store and distribute data on the network. The Filecoin token, FIL, is the native crypto token of the Filecoin network, similar to Bitcoin and Ether. Token holders can use FIL to participate and transact in the Filecoin network. In particular, users pay miners in FIL to store or distribute data and to retrieve their information. Storage providers also post FIL as collateral to provide a minimum level of guarantee of their service, which gets slashed should a deal with a customer fall through. Filecoin is looking to provide an alternative to traditional online storage providers and protocols. Its technology acts as an incentive layer for the peer-to-peer transfer system, IPFS, which uses hash-addressed content structures to store data instead of centralized servers and IP addresses. This is intended to reduce redundancy, increase permanence, and improve efficiency. Filecoin incentivizes IPFS by rewarding storage providers and retrievers for contributing resources to the system. The network also comes with built-in Ethereum integration, allowing developers to access data on Ethereum's blockchain and interact with its smart contracts. Filecoin is being developed by Protocol Labs, a development firm founded in 2014 by Juan Benet. Benet and crew constructed Filecoin and IPFS in tandem, raising a few seed equity rounds to fund the process. In 2017, the team hosted a token sale to secure funds for Filecoin's development, which raised around $205 million, and one of the largest token offerings at the time. Protocol Labs seeks to build a fundamental layer for data infrastructure that can be used by both blockchain and traditional providers like Amazon Web Services, AWS, and Microsoft Azure. The project plans to achieve this goal by creating a marketplace in which any user who has storage capacity can connect to the network, creating a supply of unused storage both in consumer hardware as well as data centers of existing businesses. The Filecoin team believes this will reduce the price of storage in a way similar to how sharing economy companies like Airbnb reduce the price of short-term rentals in marketplaces that were traditionally dominated by large players with large capital requirements. Now, let's take a look at its roadmap. In March 2019, use case-specific DevNets opened to protocol developers, miners, and other users to work with. In June 2019, testnet of Go Filecoin nodes started in the 100s, gradually ramping up orders of magnitude. September 2019, AlphaNet, which is a long-running Filecoin network, launches. December 2019, Filecoin's first public testnet will allow prospective storage miners and clients to start experimenting with the mining hardware requirements and the data storage and retrieval capabilities of the network. The testnet also provides developers with the resources to begin building Filecoin-based applications. The testing ground only supported the Lotus client at launch, but the team plans to connect other implementations, including Filecoin's Go client, before moving on to Phase 2. May 2020. The team expects to enter its second testnet phase with multiple secure and interoperable Filecoin implementations. Testnet Phase 2 will also include a security review and audit for all clients as well as a trusted setup ceremony, which will help prepare the project for its mainnet launch. The team anticipated for this phase to run until June 26, 2020, setting up the network for a tentative mainnet launch in mid-July or August. Filecoin was initially expected to release Phase 2 around February 24th of 2020, but ended up pushing back the launch date multiple times for reasons related to ensuring network stability and the coronavirus pandemic. August 2020. Filecoin launched an incentive testnet to encourage prospective developers and miners to stress test the network prior to its mainnet launch, which was anticipated for September 2020. The event will run for 3 weeks and will involve miners competing to onboard as much storage capacity as possible to the network. The top 100 miners globally will earn FIL token rewards based on how much storage they and the network achieve during the test period. Any rewards earned will be encoded into the Genesis block and will vest linearly over 6 months from mainnet launch. October 2020. The Filecoin mainnet launched at block 148,888, which arrived on October 15, 2020. It will introduce its long-awaited file storage network with mining incentives for those providing storage resources. The event also began to distribute Filecoin's native token, FIL, to crowd sale investors that first purchased the token back in 2017. The Filecoin protocol intends to use proof of replication or ProRep and proof of spacetime POST to prove files are stored securely over time within a decentralized network. ProRep is a type of proof of storage featuring the specific properties that outlined in this post. POST defines the mechanism by which miners create blocks that are storing data. Clients or network users can source miners of data storage and data retrieval, different operations that exist within separate decentralized markets. POST provides a level of verifiability so that data can be stored and retrieved in a distributed, multi-market system. Mining. Storage miners can earn FIL by storing data for clients and computing cryptographic proofs to verify storage across time. Unlike proof-of-work mining, the probability of earning a block reward and transaction fees is proportional to the amount of storage the miner contributes to the network. On the other hand, retrieval miners can receive FIL by winning bids for a client request. The market value of the file in question determines the miner's payout, available bandwidth and initial response times for details, which could be influenced by network latency or proximity to a client. This will impact the miner's ability to close deals and retrieve data on the network. Therefore, the maximum bandwidth of a retrieval miner will set the total quantity of deals they can win. With the network still in development, the mining equipment specifications, specifically for CPU and RAM, remain unknown, but the team insists that the mining hardware will contain configurations with many standard hard drives, that any specialized Filecoin mining hardware will not exceed anything more than a highly optimized hard drive, in a sense. Not optimal for ASICs. Filecoin also notes that early storage and retrieval miners will be required to run full nodes. Protocol Labs introduced many new technologies in its Filecoin white paper that could add value to multiple blockchain projects. Filecoin is secured by proof of work in the same way that Bitcoin is, but this work is specifically related to storage of data instead of finding a random nonce to make the block hash fit in a target range. The network's proof of work is restricted to proving that a miner has stored data for a specific duration and replication. This is achieved with two new types of proof of work: proof of replication, ProRep, and proof of spacetime, POST. Proof of replication allows a server to convince a user that some data has been replicated to its own uniquely dedicated physical storage, while proof of spacetime allows an efficient prover to convince a verifier that they are storing some data for a specific duration of time. These proofs allow Filecoin to solve issues with large-scale storage networks made of independent parties by making it theoretically impossible to falsify data storage records to increase miner rewards. Competitors like Siacoin SC and Storj lack this functionality, though they have not yet created enough storage demand for this to be a significant issue. Miner proofs are used to create a network based on three primary methods: put, get, and manage. The put and get methods are responsible for putting data in storage and accessing it on client request respectively. The manage method is responsible for managing the marketplace by matching buy and sell orders, as well as managing buyer and seller reputation on the platform. These methods are executed across two marketplaces, storage and retrieval, which are managed by the different miners. Protocol Labs believes that miners will often participate in both markets. Storage miners are responsible for receiving put requests and storing client data, while also pledging collateral proportional to the data. They will be penalized by losing this collateral in the event of invalid or missing proofs. Storage providers run the manage method in conjunction with clients and auditors. Retrieval miners are responsible for managing GET requests and giving clients their data. While retrieval miners do not need to pledge collateral, they are still compensated in the native Filecoin for performing work for the network. Once the network launches, the Filecoin Foundation references in the project's white paper will take the responsibility of coordinating and funding future protocol improvements and development. The Foundation is Protocol Labs' solution for the long-term governance and support of the Filecoin protocol. Protocol Labs has not released any other details on the Filecoin Foundation to date, but the Foundation will remain inactive until the network launches. This foundation will receive 5% of the FIL tokens created at Genesis to help fund future initiatives. To conclude, Filecoin is a decentralized cloud network that allows users to rent out their excess storage space, leveraging the platform's open source capability. On the other hand, end users who are not providing storage space can also buy storage on the network. Unlike centralized storage systems, Filecoin stores end users' data using a peer-to-peer blockchain network rather than on a single server, as with other centralized storage providers like Google Drive, Microsoft Azure, etc. More so, Filecoin allows users to store a wide range of data, including in-web services, movies, podcasts, contract data, DApp services, security archives, and many more. Notably, Filecoin operates in the same manner as most decentralized blockchain initiatives, with the exception that participating nodes process data storage in place of cryptocurrencies. Filecoin also acts as an incentive layer built on Protocol Labs' IPFS, Interplanetary File System infrastructure, that enables peer-to-peer storage and sharing of data files. Specifically, Filecoin turns the underlying IPFS storage system into a so-called algorithmic market, allowing users to pay storage providers in FIL, the platform's native token, in order to store and distribute data on the network. Filecoin is built on an IPFS blockchain architecture that uses a hash-addressed content structure to store data in place of centralized servers and IP addresses. This type of underlying blockchain architecture ensures that the entire network is constantly operating at a full capacity, implying that there is increased permanence and efficiency with little or no redundancy. While IPFS provides the fundamental storage architecture, Filecoin protocol interacts with nodes that are either storage providers or retrievers, and subsequently rewarding them for contributing resources to maintain the network's smooth operation. On the other hand, Filecoin protocol, just like Bitcoin, employs a proof-of-work POW consensus mechanism. However, unlike the flagship cryptocurrency, the Filecoin POW consensus mechanism functions specifically for the storage of data. As a result, in place of validating transaction on the blockchain, the Filecoin POW in its case proves that a miner or node has successfully stored data for an agreed period of time and replication. Furthermore, the Filecoin POW system employed can achieve these outstanding feats by leveraging two main subtypes of proof of work. The first is called proof of replication, which validates whether a stored data has been reproduced, while the second is proof of spacetime. These two proof of work systems function concurrently to validate the activities of a node over an agreed period of time and replication.